Hi, we're going to do some algebra problems to get you ready for the different types of things that will be part of calculus problems all throughout the course. And just kind of trying to get your mind revved up back into the math this summer. So here we go, some algebra problems. With this first, you know that when you're multiplying a two-parter times a two-parter, we want to use the distributive property, and sometimes you may remember that that is short named the word FOIL. For the first times the first, 15x to the third, remember that we add the powers when we multiply like bases. The outer of the whole problem, so the 5x times the 6, would be a 30x, and they were both positive, so plus 30x. The inside, positive 2 times 3x squared is a positive 6x squared. And then the last of each one, the 2 and the 6, they're both positive 12. At that point, if any of these were like terms, we would add them together. They're not. What I would suggest on this is rearranging it in descending order. And that would be your final answer for multiplying those two. Okay? And remember, this is a video, so anytime you need to stop this, pause it, whatever, to write something down, to go back and listen again to something I said, remember you can do that. So, and also if you have any questions, just send me a text or a email, asking me, and refer to the video about the algebra review, number whatever, or something like that, Okay, this one is a huge careless error spot for students, even at the level of calculus. You've got to remember you cannot just do x to the second power and 6 to the second power. You've got to remember what this is really saying, and it's saying that the x plus 6 is being multiplied by itself. And then we would FOIL that out, so we would get the x times x, the x times this 6, the inside 6 times x, so another plus 6x, and the last 6 times 6, 36. Now on this one we do have like terms, so we would simplify that and end up with x squared plus 12x plus 36 for the final expression there. Okay, on number 3, we've got one single fraction being divided by one single fraction. Now, as long as that's the case, we want to keep the first one and then rewrite it as times the reciprocal of the second one. So that means I'm going to keep 2 over 5x times, and now I'm going to flip the bottom one, 10x over 3 plus x. Okay, now at this point you may be thinking about canceling out something. You have to remember though that you can only cancel out common factors, not a part of an addition or subtraction. Those are not factors, then they are called terms. 3 is a term, x is a term. The whole 3 plus x is a factor though. So if there were another whole 3 plus x up here, we could cancel them. But for instance, this x cannot go out with this x. Okay? But right here, this x is a factor because it's x times that 5. This x is a factor up top. So I can cancel those. And then the 5 is a factor of both of those. 5 goes into 5 and 5 goes into 10. 1 time down there, 2 times up top. And now to finish multiplying, we go straight across the top and straight across the bottom. 1, let me draw my little lines through those. 1 times the 3 plus x. Okay. Alrighty, so let me pause for a sec. Okay, so now on this one, the difference from this one to the one we just did is that I do not have one single fraction being divided by one single fraction. So I cannot just straight multiply by the reciprocal. Instead, what I have to do here, I have to multiply every term by the least common denominator of the whole problem. So I'm looking here and here to get the LCD. Well, for a 2x and an x, the LCD would be 2x. So I'm going to go in, I'm going to multiply every single term by that 2x, whether it's a fraction or not. And what that's going to do on the ones that are fractions, it's going to make them cancel out those denominators. So up top, 2x times 4, that was not a fraction, it's just an 8x. But now, 2x times 3 over 2x, those cancel and leave just plus 3. Down bottom, the x will cancel. I'm going to have the 2 times the 5, so a 10 minus, and now these will multiply together, 12x. Okay, there's not any common factors that I could cancel out, so that would be it. Again, I cannot do something like canceling between the 3 and the 12. I can't go 3 goes into 3 once, 3 goes into 12, because of the plus and the minus sign there. 3 is not a factor of that whole expression. 3 is not a factor of this whole expression. We can only cancel out common factors. Okay. Alright. Basic exponent rules. Again, from Algebra 1 days. We want to remember that when we multiply like bases, we add the exponents. So this would be 2 plus 3 is 5 plus 4 is 9. So this would be x to the 9th. If there had been numbers out in front of those coefficients, they would actually have multiplied. Okay, jumping over here to the right, number 6, just because it's sort of the reverse of that one. Okay, if we are dividing like bases, we subtract the exponents. So this would be x to the 4th. If the 7 had been on the bottom and the 3 up top, then my x to the 4th would have been down bottom, and I would have put a placeholder of 1 over. Look at number 7 right here below. They're still like bases, x and x, so I want to subtract the powers, but my largest is right down here. So that means when I subtract, I'm going to have x to the 4th down bottom. Well, there's not anything else in the problem that could go up top, so I just have to put that placeholder of 1. Okay, to the left over here, number 2, when we have a negative exponent, remember that means it's 1 over the same base, but to the positive power. 1 over 4 to the 3rd. If the negative exponent is down bottom, look way over here at number 8 in the bottom. Then to lose that negative on the exponent, you would move it up top, and it would be x to the positive 3 when you move it up top. So if you've got a negative exponent already up top, then it moves down bottom and turns positive on the exponent. If it's down bottom, like over here on number 8, you move it up top and it loses the negative on the exponent. Okay, also on one like this, you could go ahead, just depending on the way the directions are stated, and figure out what 4 to the 3rd is. 4 times 4 times 4. And so I'm thinking that is 64. So if the direction said to write it with a positive exponent, you'd probably leave it like the first 1 over 4 cubed. If it says simplify completely, they would most likely be wanting the 1 over 64. Okay, on number 3, some of these are the negative exponents right here. So x to the 3rd is going to stay where it's at. 1 over y to the 5th. And 1 over z to the 1st. Well, they're multiplying, so x to the third times 1 will be up top. And then down bottom, both of these, y to the fifth, z. Okay, here we're multiplying. We've got like bases of just the x, and we've got coefficients. So we're going to multiply the coefficients. We're going to add the exponents. 35x to the sixth. But now, look, I've got verses because these two, the difference is we've got parentheses. So on this one, 5x is being squared. So the whole thing is being squared. 7x in parentheses. The whole thing is to the fourth power. Okay? So that means we've got the 5 being squared and the x being squared. Over here, 7 is going to the fourth as well as the x. Okay, now your like bases are going to be x to the 6th. We're going to add those exponents. And then we've got the 25, and we've got 7 to the 4th. Let's see what that is going to be. I did not have my calculator handy. Let's see. 2401. Okay, and then we would multiply that by the 25. So we would get 60,025 x to the 6th. Because these were being multiplied. Very different from what we got with no parentheses up there. So you really have to pay attention, you know, to what your problem is saying. Alright, and now over here on the number 8. Okay, some parentheses, some not. So, when we've got the value in here, and you can see some other exponents, those are going to multiply. And it's multiplying with the exponents. So, we've got x squared, y to the third, times x to the 1 times 2, or the second, y to the 3 times 2. So the 6th power right there. Over. Now, this is what I mentioned earlier. This x to the negative third wants to go up top. So I'm going to put him right here. Times x to the third. And we've got that y to the second still sitting down bottom. Okay. Now, all of these x's up top, I would add their powers. And the couple of the y's there, I would add their powers. So I'm going to have x to the 2 plus 2 plus 3. So that's 7 times y to the 9th over y to the 2nd. And now these are being divided, so I'm going to subtract powers. So I'm going to end up with x to the 7th, y to the 7th, and nothing down in the bottom. Okay, factoring. You thought you were through with factoring when you left Algebra 1, Algebra 2. But in this course, in a few weeks, couple of weeks, it's really going to come in to a lot of our answers, needing to know how to factor. So, this again is just a little review. Alright, 3x minus xt. So, one of the most basic ways for factoring is being able to find a common factor, something that is on each term. Might be a number that's a factor of the coefficient, or it might be like a variable here. So x is common, so we pull that out front, and then it's multiplied by what's left over. So if it started with the 3x and we pulled the x out, that's a 3. The minus, and then the xt, if we pull out that x, it leaves just the t. So this is your factored form there, x times 3 minus t. Okay, now sometimes your greatest common factor may actually be a binomial. Okay, on this one's going to have a large GCF. And what's guiding us to where we're looking is the big plus or minus sign. So I'm considering this sort of like a basket or a bag, and this is another basket or bag. And I'm seeing what same stuff is in those. What same factors. Well, I've got this 5 and I've got this 10. What divides into a 5 and a 10? Yeah, 5. Okay. I've got 3 x plus 6's, and back here I've got 2 x plus 6's. So the factor x plus 6 is the same, but how many do I have in common? Well, it's always going to be the smallest exponent of those two. So I've got 3 up here, remember, versus, come on, pen, 3 up here, 2 back here. So the smaller is the 2. So my common part is the x plus 6 squared. And then for my x minus 1, see, I've got those in both bags. Again, I've got 2 versus 3. I'm going to pick the smallest exponent. So for what's in common, so x minus 1 squared is in common. So all of that is my GCF. Now, times what's left over. Out of this whole bag, if I divide the 5 out, well, there's no number left out front. I had 3x plus 6's. I only pulled 2 out, so I have 1 x plus 6 left. I had 2 x minus 1's and took 2 out. None of the x minus 1's are left. Now, here's the big plus from the middle. In the back part, I had a 10. I divided the 5 out. That would leave me a 2. I had 3x minus 1's. I only took 2 out. So, whoops, right here. Only took 2 of the x minus 1's, so I've got 1 of those. And I had 2x plus 6's. I took 2 out front, so none of those left. And so now I've got 5 times x plus 6 squared times x minus 1 squared times, and now we've got to clean this part up. So we're going to distribute back here 2x minus 2 and combine our like terms. We're going to have 3x and then 6 minus 2 would be a plus 4. And so that would be my factored form, all of that. Okay. With our trinomials, these are the good old ones where you check it out first to see if you're going to have anything in common all the way across. We do not on this one, so we go right ahead to set up our 2 parentheses. We figured that in the front of these, to get x squared, I would have to have x times x. Okay. I'll look at the signs next, not the numbers. If the back sign is a plus, then both signs that are down here, that I'm going to put in here, will match whatever I see in the middle. So both pluses. And then the 2 numbers in the back have to multiply to be 15 and add up to be the 8. And we'll put our biggest number right here to match this middle sign. So 3 times 5 is 8. 5 is larger than a 3, so I'm going to put it up there. And you could FOIL that all the way out just to double check yourself if you don't feel good about factoring. But that's what it would be there. Now over here on number 4, we start out the same way. We don't have anything in common to pull out in front, and then x times x for the x squared. Now in the back was a minus. Let's see if I can erase that right there, because it sort of ran into that. Okay, so right here, when that is a minus, you will have different signs, and the biggest number needs to match that minus. So different signs when the back is minus, and then the big number goes right there with the one that we pull straight down. And we still need to multiply to get 10, but now for different signs you want them to subtract to be a 9. So 10 minus 1, and 10 times 1 is 10, and 10 minus 1 is 9, and the biggest number would get the negative, so negative 10 plus 1 would be negative 9, and so that would be your factored form there. Now right here, this is another, we want the greatest common factor. Okay, so, and again I'm letting that minus sign split it up. So 2 and a 50. 2 is common of those. X and x. Y squared, no y's. So there's no y's in common. And then times what's left over. So 2xy squared. If I pull out the 2 and the x, I've got y squared left, minus, and then 50 divided by 2 would be a 25. The x divided by the x, no x's right here. Now, you might think you're finished, but now look at what we've got right here. We've got one of those good, easy, real common rules, the difference of two squares. And so that's the one, we would keep this out front, and then you would have the two parentheses, one with the minus sign and then one with the plus sign. And the square root of y squared would be in the front of both of them. The square root of 25 would be in the back of each one. Sorry about that. Okay. So 2x times y minus 5 times y plus 5 would be your final completely factored problem. Okay. Now, I've already mentioned a couple of times, to reduce a fraction, you can only reduce or cancel out common factors. So you must factor these first and then look to see if anything is common that we can cancel out. Okay, so up top, we've got the 3. We would do our factoring. Okay. Why don't you hit pause and see what you get for the top factored and the bottom. Okay, and then start it back up. Okay, so hopefully you got x and x. You had same signs because the back was a plus, same as the middle. And then multiplying to be 6, adding up to 5. So we should have had the 3 and the 2, not a 6 and a 1. Down bottom, this is a difference of two squares. So you should have had the x minus and the x plus. And then the square root of 4 is a 2. And so now the common factor that completely matches is the x minus 2. So we end up with 3 times x minus 3 over x plus 2, which would be 3x minus 9 over x plus 2. Okay? So, functions. What do you remember about functions? Well, maybe we remember, or you remember, that in order for a match to be a function, each beginning part, each domain, each x, like right here, can only have one match. So what the C is doing, only going to Y, is good. What the B is doing, only going to Z, is good. But the fact that we've got this A going to the X and the Y means that you do not have a function. Okay. Now another way to tell if you've got a function or not is the vertical line test. So, you know, picture vertical lines going all through this. If any one touches more than one point, that means that the X is having more than one match. So, on this one, this is what you would want. Each of those vertical lines that you could picture only touch once. So that means it is a function. Versus over here, you know, if I picture a vertical line going through there, it is touching here and here. Those X numbers for those two ordered pairs are going to two different Y numbers. That is not allowed to be in order to be a function. Okay, your function notation, something like this, f of x equals 3x squared plus 2x minus 6. Find f of 4. So remember, this is telling you your x number right there. Okay, and it's telling you the x that it wants plugged in, the number or expression that it wants plugged in. So we would just rewrite it. We would plug in that x number. And then we would do the arithmetic in this case. So square it first, if you're not shoving it straight into a calculator. 3 times 16, 48. Plus the 2 times 4 is 8, and then minus 6. So 48 plus 8 is going to be 56, and then minus 6 equals 50. So f of 4 equals 50. When x is 4, y is 50. Okay? Alright, now on this one, it's the same idea, but we are plugging in an expression. The whole x plus h is having to go right here. Right for that x. Let's see my little pen. There we go. Alright, so 8, plug in the whole x plus h. Whoops. My goodness. Come on, pen. Yep, I have difficulties like this in the classroom sometimes too. Alright, and then plus 6. So now I'm going to distribute, but not to the 6 because it was not inside the parentheses, and none of those are like terms, so that would be that. So whatever is right there behind the name of the function is what you're plugging in, whether it's just a simple number or whether it's an algebraic expression. Okay, let's review for a minute interval notation. How to write something like x less than or equal to 7. Well, first, if it's been a while, the best idea is to graph it on a number line. So if we're graphing x less than or equal to 7, the or equal says we would want to include 7. And then less than, it would be going back here to the left. Okay, well think about what we call that left. That just goes negative, 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 negative forever. So that's our negative infinity. The interval notation then names this interval, this section, from left to right, from smaller to larger. Parentheses always goes with an infinity or negative infinity, and then a comma for saying how far it's going, and then the right, we're going through 7, and since it can be equal to it, we have the bracket. And that's your actual interval notation. On the one over here, this is saying that your x is going to be in between just like it's written up there, the 2 and the 8. Now the 2, it just says 2 is less than x. So this would be an open circle. But over here it says it could be less than or equal to the 8. So that would be a solid circle. So my interval notation, parentheses, 2, meaning it's not or equal to, and then all the way to 8 and including it. Okay, and let's see if I'm missing any others down there. And so I think that is the end of my little review there. And so you've got some homework problems in my math lab in D2L, so good luck with that. Do not get behind, please. The next video I'll be starting on is the first section of the actual calculus ideas, dealing with limits. And I will see you then. Well, you'll hear me then. Bye.